In this video, we are going to be talking about exponents and exponent rules and working with them a little bit to simplify expressions. First off, what is an exponent? I guess an exponent is a little number that you typically write above another number, or I guess above a letter, or above anything. If you have a box squared or a square root of x squared, any of these numbers here, and it doesn't have to be a 2, it could be a 12 or whatever, those numbers are called exponents. Reason why we use exponents is just, I guess it's a short form of writing a multiplication, and that's what we're looking at, is it multiplication. So what this 4 to the third means is it's 4 multiplied by itself 3 times. So it's not 4 times 3. That's not what this 3 means. The 3 means I have 4's here and I have 3 of them. So 1, 2, 3, there. X squared, that would be 2 x's. A box squared, that means I have 2 boxes. A square root of x to the 12th means, yeah, I'm not going to write all of those, but you get the idea, that there'd be 12 of them. Now, places where they're used, we have lots of equations. You've probably used them before. Here's one, pi r squared, area of a circle. Volume of something, pi r cubed. I think it's 4/3 pi r cubed. Anyway, there's an exponent. And there's lots of times where we have exponents. So we need to be able to use the rules for those. So if I'm taking a look at these, and you can maybe want to pause and just see if you can rewrite those as the multiplication of something. So 3 to the 4th, what does that mean? X to the 7th, what does that mean? So pause and maybe write down what you have there. Okay, hopefully you've pressed play, and if you wrote something like this, that's perfect. Notice the difference between these two here. This one, I just have 2x cubed. That 3 only pertains to the x. It just says I have 3 x's. But in this case here, the 3 means I have 3 of whatever's in brackets. So, and notice that the answer to each of those will be different. Like this one in the end will be 2 times 2, so it'd be 16x to the 4th or 3rd. Oh, how come I have 4 there? There should just be 3. Oh, that's not right. So 2x cubed would be, there'd be 3 of those, so the answer would be 8x cubed. Whereas the answer to this one is just 2x cubed. So these two are different. Be careful with that. Now, there are 2 special occasions where you have an exponents, where you get something, I guess it's not different that happens, but something you need to remember. If you ever have anything to the first exponent, it just means it's that number. So if you have a box to the first, it just means you have a box. If you have the square root of x to the first, it just means you have the square root of x. The other one is if you have something to the 0 power. Anything to the 0 power, doesn't matter what it is always equal to 1. Okay? So star to the first, that's just a star. Heart to the 0, anything to the 0 power is 1. This whole convoluted thing, if it's raised to the 0 power, it's equal to 1. And remember that when we're looking at some questions. Okay, now when we're using exponents, we often are using them within an expression, and like this one, where it means something else, we're saying x could mean something, and often we're plugging numbers in. So when I'm plugging or evaluating an expression for a specific number for x, I always like to take this x cubed, so that's my expression, and wherever there's an x, I put a bracket, cubed. And then I go back to see what I have to plug in. In this case, I have to plug in a 4. And now 4 cubed means 4 multiplied by itself 3 times. And 4 times 4 times 4, I think, is 64. Here's another one we can try. Area equals s squared. So this would be an area of a square. When s is 6, so area is equal to s, I'm not sure, squared. Now I go back in and I plug in whatever s was. They're saying it's a 6. So 6 squared is equal to 36. Okay? Maybe try this one. This is a sort of a nasty one with a negative one, but try that one. And then press play and see if you get it right. So I would plug in a -2. There's an x there. I put in a bracket to the 4th. Now I plug in my number. X is a -1, so I plug that in there. Have to do your order of operations, so brackets, there's nothing I can do in there, but I do exponents first. Notice I don't multiply these, I do exponents first. So -1 to the 4th really means -1 times -1 times -1 times -1. And I have a -2 out front there. So 1 times 1 times 1 times 1 times 2 is just going to be 2. Now it's just a matter of whether it's positive or negative. An easy way, if you're multiplying those, that you just get two negatives, make it positive. So these two here, positive. These two here, positive. And this one, I don't have one to cancel it with, so I'm stuck with it. So my answer to this evaluation would be -2. Okay, let's look at the two rules that are typically used with exponents. First rule is the product rule, and it says if you're multiplying common bases, in other words, if the base is identical, then what you can do is add the exponents. So if I'm multiplying 4 cubed times 4 squared, the answer is going to be 4 to the whatever I add those things to be. So 3 plus 2 is 5, so it's 4 to the 5th. You could write that out, I guess, as 4 times 4 times 4, and then this one is 4 times 4. And if you wanted to write it all out together, there's how many altogether? There's 5 of them. And rather than writing them all out like I did there, you can just write 4 to the 5th. Same thing here. It doesn't matter what you have. If the bases are the same and you're multiplying, which we are here, you leave the base alone and just add the exponents. Try these. Try those. See what you come up with. And then press play. This one, x to the 8th. This one, ooh, there's a bunch of b's there. That's okay. Common bases, I multiply and I just add the exponents. 16. This one doesn't have exponent. But we know that if you don't have 1, we assume it to be a 1. So if there's a base that doesn't have an exponent, assume to be a 1. So 1 plus 5, 6. So y to the 6th power. So if there is a product rule, there's got to be a quotient rule. And that says if you're dividing common bases, here I'm dividing common bases, subtract their exponents. So 5 take away 3, x squared. Here's a couple to try. Again, press pause and press play when you're ready. Okay, so this first one I'll just reveal here. Dividing common bases, subtract their exponents, you get this. You don't have to write that middle step in there if you don't want to. You can just go right to there if you want. Here's one where I have more than one base there, and so these aren't common bases, so I can't add those. But these are common bases, and I'm dividing, so I can subtract those. So this would be a to the 4 minus 2, b to the 9 minus 7, so a squared, b squared. Again, if you don't want that, put that step in there, perfectly fine to go right to there. Now, sometimes when you're dividing things, you get negative exponents. Take a look at this example. So 16 is the same as 2 to the 4th. 64, 2 to the 6th. So if you are dividing, there's common bases. I'm supposed to subtract exponents. So I'm supposed to go 2 to the 4 minus 6. Notice how I always write the exponents real small and I write them up high. That's good. If you write it something like this, then you get mixed up. Is this an exponent or is this a base? So make sure when you're writing them that you write your exponents up nice and high and smaller. Okay, 4 take away 6 is a -2. So how does that work? I guess when you're following the rules, that's what you do. If you're dividing common bases, subtract their exponents, sometimes you get negative exponents. But when you take a look at this, this could really have also been written like this. Notice that these 2's cancel if I was dividing, and these would all be 1's, right? So on the top, I'm going to have a 1, and the bottom, I'm going to have 2 times 2, or 2 squared. So notice that if I have a number that has a negative exponent, this is perfectly fine, but sometimes they want you to write it with a positive exponent. So you have to write it as 1 over 2 to the positive 2. And that's sort of the rule when you're dealing with negative exponents. is that any negative or any number with a negative exponent can be rewritten with a positive one just by flipping it on the other side of the fraction line. Notice that only the number or letter with the negative exponent moves. So like in this case here, this y is positive, so it stays where it's at. But the x is negative, it's going to move to the bottom. And the z here is negative on the bottom, it could just move up to the top. Like in this example, 2 to the minus 2, that I could write that as over 1, and this one would move to the bottom. Likewise here, the a is to the positive first, so it just stays there. But the b is on the negative on the bottom, I can move it up to the top, and it'll become positive on the top. Here's something to try. Go ahead and try those. Press pause and then press play. Okay, so I could rewrite this as, there wouldn't be anything on the top, so I'd leave it as a 1, because I can always write this as 1 times something. So I still have a 1 on the top, and on the bottom I have 5 cubed and 5 to the positive 2. Top to the bottom changes the sign. Now in this particular case, since these are common bases, I can rewrite that as 1 over 5 to the positive 5, because I'm adding exponents. If I'm multiplying common bases, even though they're on the bottom, I can add their exponents. Or that would be 1 over, I don't know what 5 times itself 5 times is. It's a big number. 625 times 5, yeah, through 3, I don't know what it is. Anyway, you could figure that out. Notice I could have done this question another way. That one there, I'm dividing, and these are common bases, so I could have subtracted the exponents. So I could have said 5 to the negative 2 minus 3. And if I subtract those, I'm down 2, lose another 3, it'd be down 5. So I could have rewritten this one right off the bat as this, because they were common bases. If I wanted to make them a positive exponent, I could switch it to the bottom like I had here. Same thing with this one, I could have taken that to the bottom, so 4 to the 6th over 4 to the positive 3. Dividing common bases, I can subtract their exponents. I get 4 cubed, I think that's 64. But I also could have just used the product rule. I'm multiplying common bases, add exponents. So it'd be 4 to the minus 3 plus 6. And 4, I'm down 3 again, 6, I'd be up 3. Again, I'm getting the same answer as I had before. So it gives you a little bit of practice on what exponents are. We looked at the product rule and the quotient rule, and then what happens when I come up with negative exponents. Okay, try some questions.